starting with number 1 Polikarpov I-153 Chaika. Soviet Union, 1938. The I-153 entered Soviet service as a biplane in an era when the world had already moved on to monoplanes. Designed for the Sino-Japanese and Finnish conflicts, it was nimble but fundamentally obsolete the moment it arrived. Pilots quickly discovered that its retractable undercarriage, meant to reduce drag, frequently jammed, sometimes refusing to extend before landing. Several pilots died in gear collapse crashes. Those who survived the mechanical failures still face slaughter from faster German monoplanes over the Eastern Front, where the Chaika became a flying coffin for hundreds of VVS airmen. 2. Polikarpov I-16 Tipo. Soviet Union, 1934. The I-16 was revolutionary when it first flew, a stubby, round-nosed monoplane that gave Soviet pilots the world's first retractable gear fighter. But revolution came with a cost. Its center of gravity was dangerously forward, and its controls were so sensitive that even veteran pilots described it as trying to kill them on every flight. Spins developed without warning, and recovery was almost impossible at low altitude. During the Winter War and the opening of Operation Barbarossa, hundreds of I-16s were lost not to enemy fire, but to pilot error induced by the aircraft's own unforgiving handling characteristics. 3. Petlyakov P-2. Soviet Union, 1941. The P-2 was the Soviet Union's answer to the German Ju-88, a fast, twin-engine dive bomber that became the backbone of Soviet tactical bombing through the entire Great Patriotic War. But speed and capability masked a deeply dangerous machine. Its dive brakes were notoriously unreliable, and crews who entered steep dives without proper brake deployment found the aircraft accelerating beyond controllable limits. Numerous crews were lost to compressibility effects before Soviet engineers fully understood what was happening. Pilots who survived called it demanding, unforgiving, and relentless, an aircraft that rewarded precision and killed those who hesitated. 4. Aviation Il-2 Shturmovik. Soviet Union, 1941. No Soviet aircraft carries more weight in history, or more death. The Il-2 was armored, ground-pounding, and terrifying to Wehrmacht troops below. But its single-seat early variant left the rear completely undefended. German fighters learned immediately: attack from behind. Loss rates in 1941 and 1942 were catastrophic. In some regiments, average pilot survival lasted fewer than 10 missions. Stalin himself sent furious telegrams demanding production continue at any cost. The two-seat variant added a rear gunner, who often died protecting the pilot. The aircraft that saved the Soviet ground war consumed its own crews at a staggering rate. 5. Lavochkin Lag-3. Soviet Union, 1941. Soviet pilots had a grim nickname for the Lag-3, varnished guaranteed coffin, a dark play on its wooden construction. Built from a composite wood material called Delta wood, the aircraft was heavy, sluggish, and painfully underpowered for the fighter role it was asked to fill. Against German Bf-109s over the Eastern Front, Lag-3 pilots faced a brutal equation. Their aircraft climbed slowly, turned heavily, and dived poorly. Hundreds of pilots were killed in engagements where they simply could not escape. The design was so poor that many experienced Soviet aces refused to fly it, demanding reassignment rather than face combat in a machine they considered a death sentence. 6. Yakovlev Yak-1. Soviet Union, 1940. The Yak-1 was meant to be the modern Soviet fighter that replaced the I-16's dangerous instability. In many ways it succeeded, but it introduced its own quiet lethality. Early production variants suffered from engine fires caused by fuel system leaks, cockpit fumes that incapacitated pilots, and canopy designs that refused to open in emergencies. Multiple pilots drowned in crash landings because they could not exit the aircraft in time. Quality control in Soviet wartime factories was so inconsistent that two Yak-1s off the same production line could handle entirely differently, making training almost meaningless for preparing pilots for what they would actually fly in combat. 7. Mikoyan-Gurevich MiG-1. Soviet Union, 1940. The MiG-1 was designed for one purpose: speed at high altitude. It achieved that purpose brilliantly, and almost nothing else. At lower altitudes where most Eastern Front combat actually occurred, the aircraft became unmanageable. Its engine torque was so violent during takeoff that pilots who failed to apply aggressive opposite rudder immediately found themselves cartwheeling across the runway. The cockpit was cramped, visibility was terrible, and range was so limited that meaningful combat missions were nearly impossible. Dozens of pilots were killed or injured in takeoff and landing accidents before the MiG. One was quietly pulled from frontline service in favor of the improved, but still troubled MiG-3. 8. Mikoyan-Gurevich MiG-23, Soviet Union, 1941. The MiG-3 corrected some of the MiG-1's worst characteristics, but inherited its fundamental problem. It was a high-altitude interceptor deployed in a war fought at medium and low altitudes. Soviet pilots sent into combat in MiG-3s against Luftwaffe fighter sweeps below 5,000 meters found themselves at an enormous disadvantage. The aircraft's handling deteriorated sharply at lower altitudes, and its engine was prone to overheating during the prolonged maneuvering that dogfights demanded. Production was eventually canceled not because the aircraft failed in concept, but because the war it was built to fight never materialized at the altitudes where it could have excelled. 9. Aviation IL-4, Soviet Union, 1936. The IL-4 was the Soviet long-range bomber that carried the war to Berlin in the conflict's early stages, a remarkable achievement that history often overlooks. But the aircraft that flew those missions did so at enormous cost to its crews. Its defensive armament was inadequate against German interceptors. Its oxygen systems frequently failed at the altitudes required to avoid flak, and structural fatigue cracked airframes that were being pushed beyond their design tolerances. Navigational equipment was primitive, and crews were often lost not to enemy action, but to disorientation over featureless terrain at night. Entire crews simply vanished, their fates never confirmed. 10. Tupolev Tu-22, Soviet Union, 1942. The Tu-22 arrived as one of the most capable Soviet bombers of the entire war, fast, well-armed, and far more survivable than the aircraft it supplemented. But its introduction was plagued by a problem that cost lives before combat ever intervened: production defects. Early aircraft suffered from hydraulic failures, bomb bay doors that refused to close, and undercarriage collapses on landing. Test pilots at Soviet acceptance facilities were killed evaluating aircraft that should have been caught in factory inspection. The Tu-22 eventually matured into an excellent machine, but the path to that reliability was paved with the deaths of the men who flew imperfect examples. 11. Yakovlev Yak-39, Soviet Union, 1942. The Yak-39 became the most produced Soviet fighter of the entire war, and in capable hands it was a formidable opponent. But mass production in desperate wartime conditions introduced a problem that pilots discovered too late: fuel tank seals that degraded and leaked, filling cockpits with fumes that could ignite without warning. Several pilots were burned alive in aircraft that caught fire not from enemy bullets, but from their own fuel systems. Simultaneously, early variants carried wooden wing spars that developed cracks under the stress of aggressive maneuvering, wings that, in extreme cases, simply separated from the fuselage during high-speed dives. 12. Lavochkin La-5, Soviet Union, 1942. The La-5 was the aircraft that changed the air war over Kursk, more powerful than the Lag-3 it descended from, genuinely competitive against the Bf-109G. But it harbored a hidden killer. The engine air intake was positioned in a way that drew cockpit air over the engine, raising internal temperatures to levels that left pilots physically incapacitated during long missions. Reports of pilots passing out from heat exhaustion during combat were not uncommon. In winter operations, the same design flaw worked in reverse, exposing crews to brutal cold. The La-5 could defeat the enemy and still destroy the man flying it. 13. Aviation IL-10, Soviet Union, 1944. The IL-10 was developed as the successor to the legendary IL-2 Sturmovik, incorporating lessons from years of brutal close support combat. It was faster, better armored, and more agile than its predecessor, and it still managed to kill its own pilots. Hydraulic system failures were endemic in early production aircraft, leaving pilots unable to lower undercarriage or control flaps during approach. Several IL-10s were written off in belly landings caused entirely by systemic hydraulic failures. The aircraft entered service late in the war and saw limited Great Patriotic War action, but continued killing crews in post-war operations across Soviet client states into the 1950s. 14. Mikoyan-Gurevich MiG-23, Soviet Union, 1946. With the war over, Soviet aviation pivoted violently into the jet age, and the MiG-9 was the first painful step. Powered by reverse-engineered German BMW and Jumo jet engines, the aircraft was the Soviet Union's admission that it was still catching up. The most dangerous characteristic was one that seemed almost absurd. Firing the nose-mounted cannons at high altitude caused the engines to flame out. The propellant gases from the guns were ingested by the intakes and smothered combustion entirely. Test pilots experienced complete engine failure during weapons trials. Combat use was essentially impossible until the problem was partially resolved, leaving the aircraft operationally useless at precisely the role it existed to perform. 15. Yakovlev Yak-38, Soviet Union, 1946. The Yak-38 was Soviet pragmatism at its most transparent, a piston-engine airframe converted to jet propulsion by bolting a captured German Jumo 004 engine beneath the nose. The result was a machine that handled like a jet and broke like a prototype. The exhaust from the undernose engine directed a continuous stream of superheated gases across the lower fuselage, burning through structural components and destroying the tail section if flights exceeded conservative time limits. Pilots were instructed to land after precise maximum durations, an instruction that, in several incidents, came too late. The aircraft was a transitional compromise that asked pilots to trust a machine its own engineers did not fully trust. 16. Mikoyan-Gurevich MiG-23, Soviet Union, 1947. The MiG-23 shocked the Western world over Korea. Fast, high-flying, and more capable than almost anything opposing it in the conflict's opening months. But beneath that performance lay characteristics that killed inexperienced pilots with mechanical efficiency. At high speed, the controls became so heavy that pilots could not physically deflect them enough to recover from dives. At low speed, the aircraft was prone to entering uncontrolled spins, from which recovery required both skill and altitude that combat rarely provided. Soviet and Chinese pilots trained in short, compressed programs died in significant numbers not in air-to-air combat, but in accidents caused by encountering the jet's handling limits before they understood what those limits were. 17. Mikoyan-Gurevich MiG-23, Soviet Union, 1952. The MiG-23 was introduced to correct the MiG-15's worst aerodynamic habits, and it succeeded, producing a fighter that was genuinely pleasant to fly at the speeds it was designed for. The problem emerged in Vietnam, where Soviet-supplied MiG-17s met American supersonic jets and were pushed into flight envelopes they were never designed to enter. North Vietnamese pilots who attempted to extend dives to escape American missiles encountered violent control reversal, the aircraft responding opposite to inputs, resulting in several unrecoverable situations. The MiG-17 was not a poorly designed aircraft. It was an aircraft destroyed by a war that had moved faster than its airframe could follow. 18. Tupolev Tu-22 Badger, Soviet Union, 1954. The Tu-22 was the Soviet Union's answer to the B-47, a swept-wing jet bomber capable of delivering nuclear weapons to European and Asian targets. It also killed its crews through a refueling system that bordered on institutional recklessness. Soviet wingtip-to-wingtip refueling required the receiver aircraft to fly in extremely close formation with the tanker, while a fuel hose extended laterally between wingtips. Contact failures caused fuel to spray across both aircraft simultaneously. At least several documented incidents resulted in fires or structural contact that destroyed both aircraft involved. The procedure was so dangerous that crews described mandatory refueling training missions with the same dread reserved for combat operations. 19. Yakovlev Yak-38, Soviet Union, 1960. The Yak MiG-28 existed in multiple variants: bomber, interceptor, electronic warfare platform, and each variant shared the same fundamental problem: an engine layout that created catastrophic asymmetric thrust in single-engine failure scenarios. Lose one engine at low altitude and low speed, and the aircraft entered an uncontrollable roll before the pilot could respond. The interceptor variant added a radar system that partially obstructed forward visibility in a fighter expected to perform visual identification passes at close range. Soviet aviation accident records from the 1960s reference numerous Yak-28 losses, though the full figures remained classified for decades. Crews flew the aircraft knowing its single-engine behavior was a condition, not a contingency. 20. Sukhoi Su-7 fighter. Soviet Union, 1959. The Su-7 was given to Soviet allies across the Middle East, India, and Eastern Europe, and it proceeded to destroy those air forces from within. Its fuel consumption was so extreme that meaningful combat radius was measured in minutes rather than miles. Indian Air Force pilots operating Su-7s during the 1971 war found themselves turning back from missions before reaching their targets due to fuel exhaustion. Egyptian pilots lost multiple aircraft to fuel starvation during the 1967 and 1973 conflicts. Beyond range, the undercarriage was fragile on unprepared runways, and the landing speed was so high that pilots who floated even slightly beyond touchdown zones ran out of runway entirely. The aircraft was powerful, fast, and operationally nearly useless in the conditions it was actually deployed in. 21. Tupolev Tu-22 Blinder. Soviet Union, 1962. The Tu-22 holds a specific and grim distinction. It may be the most hated aircraft ever operated by Soviet long-range aviation. Its engines were mounted above and behind the fuselage in a position that created severe handling problems throughout the flight envelope. The landing approach was performed at unusually high speed, and the undercarriage was too weak for the structural loads that high-speed landings regularly imposed. Nose wheel collapses on landing were not rare incidents. They were expected events. Crews were given detailed briefings on what to do when the nose collapsed, rather than how to prevent it. Ejection seats fired downward, which was lethal below a minimum altitude that landing approaches regularly violated. Soviet crews transferred away from the Tu-22 whenever bureaucracy permitted. 22. Mikoyan-Gurevich MiG-21. Soviet Union, 1959. The MiG-21 became the most widely produced supersonic jet in history, and that ubiquity spread its particular dangers across dozens of air forces simultaneously. Its delta wing and small size made it fast and difficult to spot, but the same configuration gave it a pitch-up tendency at high angles of attack that could instantly depart controlled flight. Fuel capacity was so limited that pilots regularly ran engines dry returning from engagements, particularly in the Middle East and Southeast Asia. In Indian service alone, the MiG-21 accumulated one of the worst accident records of any jet fighter in any air force, with losses numbering into the hundreds over decades of operation, the majority attributed to mechanical failure rather than enemy action. 23. Sukhoi Su-9 Fishpot. Soviet Union, 1959. The Su-9 was the Soviet interceptor designed to destroy American U-2 and B-52 intruders before they reached Soviet territory. It had no gun. Its designers believed missiles had made cannons obsolete. When AU-2 crossed Soviet airspace in 1960, a Su-9 was scrambled from Sverdlovsk, armed with no missiles at all and carrying no weapons whatsoever, on an aircraft being ferried between bases. The pilot was ordered to ram the U-2 if he could reach it, an order that reflected both the desperation of the moment and the operational gaps in the Su-9's concept. He could not reach the altitude in time. The aircraft's narrow operational parameters made it almost irrelevant against anything that deviated from its designed threat profile. 24. Mikoyan-Gurevich MiG-23 Foxbat. Soviet Union, 1970. The MiG-23 terrified Western intelligence services for years. Its performance data suggested a fighter of near impossible capability, prompting the development of the F-15. The truth revealed when Viktor Belenko defected to Japan in 1976. was both more and less impressive. The Foxbat was not a maneuvering fighter at all. It was a straight-line interceptor built, largely, from stainless steel, with engines that could be pushed to Mach 3.2, but would be destroyed by doing so. Pilots were prohibited from exceeding Mach 2.8 in normal operations. The radar required vacuum tubes rather than transistors because transistors were unavailable in sufficient quality. The aircraft was extraordinary in its intended role and suicidal outside it. 25. Tupolev Tu-22 backfire. Soviet Union, 1972. The Tu-22 backfire was the aircraft that genuinely worried NATO strategic planners. A supersonic swing-wing bomber capable of reaching carrier groups in the North Atlantic on low-level penetration profiles. It also worried its own crews. Hydraulic system complexity made the variable geometry wings sweep mechanism a persistent source of failures, sometimes leaving the wings asymmetrically swept and creating rolling moments that overwhelmed autopilot systems. Engine inlet geometry at low altitude and high speed created pressure fluctuations that could cause compressor stalls in both engines simultaneously. Soviet naval aviation operated Tu-22 against targets in Afghanistan, a role the aircraft was never designed for, with predictable difficulties in precision and survivability. If you enjoyed this video, make sure to like the video and subscribe for more military history content. And if you noticed any mistake or detail we missed, feel free to mention it in the comments below. Thanks for watching, and we'll see you in the next documentary.